Hi class, and welcome to the midterm review. By this time you have taken your midterm exam, which has marked the halfway point in our course. Recall that our course is a cumulative course, and in June you will be responsible for all the material covered from September through June on the New York State Regents exam. Let's look at some of the questions from the review. In question 1, they ask about an atom in the ground state. Now, the term atom refers to neutral. In the question, they inform us that there are 2 electrons in the first shell and 6 electrons in the second shell. So what we'll have to do is we'll pull up our periodic table and look for an atom whose electron configuration is 2,6. On our reference table, we see that oxygen has the electron configuration of 2,6. Recall that the electron configurations tell about the placement of electrons in an atom. Now, the atomic number tells about the number of protons. And the mass number is essentially the protons plus the neutrons. So in this question, they ask about the number of protons, or the atomic number. So the atomic number of this element is 8. In question number 2, they ask about which has the smallest mass. We're looking here at subatomic particles. Let's make a chart. So the 3 major subatomic particles are protons, neutrons, and electrons. Recall that protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. The mass of a proton in atomic mass units is approximately 1, as is the mass of the neutrons, while the mass of an electron is negligible, or essentially 0. Protons and neutrons are both located in the nucleus. That means most of the mass of an atom is concentrated in the nucleus. Electrons are typically located outside the nucleus in an electron cloud. So going back to the question, we're asked to find the mass, which has the heaviest mass. So the mass of 2 electrons would be 2 times 0, which is 0. The mass of 2 neutrons would be 2 times 1. So we're getting this number 1 right here under mass. So 2 times 1 is 2. The mass of an electron and a proton would essentially be 0 and 1, so that adds up to 1. And the mass of a neutron and an electron, again, would be 1 from the neutron and 0 from the electron, so that would be 1. So the most mass is choice B. In question number 3, we were asked about 2 isotopes, isotope phosphorus 31 and sulfur 32. To find out more about these, we're going to make a chart and look at our periodic table. So here on our periodic table, we find phosphorus and sulfur. Now the numbers associated with phosphorus 31 and sulfur 32 are very similar to the numbers found in the upper left-hand corner, the mass numbers. So the atomic mass is the average mass of all the naturally occurring isotopes, but this is the exact mass of one single atom. Recall from the previous question that mass of atoms comes from their neutrons and protons. Now, in question number 1, we recalled that on our reference table, the electron configuration tells us the number of electrons in the atom, the atomic number tells us the number of protons, and the mass number tells us the neutrons plus the protons. So looking here at the elements here on the periodic table, we can see that phosphorus has 15 protons while sulfur has 16 protons. Now, if we wanted to determine the number of neutrons, since this number here is the protons plus the neutrons, all we'll have to do is subtract the proton number to determine the neutron number. So phosphorus has a neutron number of 16. And sulfur 32 minus 16, has a neutron number also of 16. So let's go back to the question. Since we can see that both atoms have the same neutron number, we can eliminate the choices that refer to neutrons. And now we can see that compared to phosphorus 32, the sulfur has one more proton. Question number 4 asks us which two notations represent atoms of isotopes of the same element. So let's think about how isotope notation looks based on our periodic table. Based on our periodic table key, recall that we have the electron configuration, which sum to find the total number of electrons. We have the number of protons represented by the atomic number, and that's a bold number. And then we have the protons plus the neutrons, or the average number of protons plus neutrons, as the atomic mass. So notice that the proton number is in bold, and that's because the proton number identifies the element. So if you're looking for elements that are isotopes of one another, they should have the same number of protons, but different number of neutrons. So here we know that isotopes have to be the same element, so we can eliminate choice C and choice D. But now we're left with two choices. And when we look at the two choices, in choice number letter B, we can see that these two choices are exactly the same. So they're not two isotopes. Instead, they're the same element. So choice B is not. And here we can see choice A has the best choice because it has the same number of protons. They're both 50, but they have different number of neutrons because the mass numbers are different.